Kind of interesting, isn't it, Frank? Interesting motor.
Yep.
I call it the schoolgirl motor.
Yeah, but there are some very complicated things going on in it.
There it actually is, see it?
Yeah.
Right? Actually, that's a good picture of it. Look at how that damn trigger level floats, right?
Yes. Now it's trying to find something. Trigger on.
So we got that. You know what the input, the output looks like, right?
Yes.
You want to go back to the capacitor now? You've got this, you want to keep this one on the bridge.
Mm-hmm.
Take this one off the motor so we don't short it out. And we'll go past, back to the capacitor so we can watch it wander up and down here. Still be way up there. And then we should come back to our pulse.
Sawtooth.
Yeah. And then the sawtooth should be, well, this is actually the DC level. See, we zeroed the scope.
Mm-hmm.
It's in DC coupling. So if we went to AC,
Yeah.
right, then you would see exactly what the capacitor is actually
Yes.
doing.
Yeah.
The charge and the
They
discharge.
normally function.
Yeah.
Mm-hmm. And they discharge.
So how do we get out of this menu now? There it is. Okay. So here we are. Now we're actually looking at what that capacitor is doing. Yep. Charge, discharge, charge. Yep.
And the time base
Okay.
isn't linear.
Well, we gotta get out
So
of the
it
menu.
must be
We gotta
round
get out of
about
the
what
menu.
calculated 800.
500 milliseconds.
Okay, yeah. So it's
We actually need to go.
no, it's our 1 second.
Yeah, it's 1 second pulse.
Yeah.
That's exactly the pulse.
Yeah.
If you count this as 1001, 1002, 1003, 1004,
Yes.
1005, and then this brush contact, right,
Yeah.
gives you that 1 second,
Yes.
the length.
Brush contact? No, this is just the revolution here.
Yeah,
The commutator.
yeah. And so you can see that on the discharge of the cap.
On the charging side.
Yeah, charge cycle and then discharge.
And then on the discharge side, well, let's look at one of the discharge cycles. Maybe we can make it long enough to see if there are
On this side,
problems.
you mean?
If there are problems with the contacts for the
Or
discharge.
you want to look across the contacts?
Yeah.
Okay.
Just
Well, I don't know, this is pretty crude, Frank. There could be problems.
but then we know
Okay, how to fix it.
how much
Okay.
potential
There
there
it
is.
is. Go down.
So far it looks
The same.
clean enough.
Yeah, it's clean.
Maybe we can make it
Bigger?
a bit longer. Yes. And even longer to see if there are any
Yep, there you go.
ripples
There
from
you
there.
go.
Looks relatively clean. So
Yeah, and this should be 1 second. Let's see, 200 milliseconds,
yeah, between
right?
one cycle and the
Yeah,
next.
yeah, it should be 1 second.
Right.
Exactly.
What I was trying to determine
Is if it's making contact.
how good of a contact this is really be, or if we have some losses there.
Well,
But obviously
we don't have any.
we can't see anything out of the ordinary.
Right, not even a carbon buildup. You see carbon buildup,
No.
and yet you can see
In
the
the-
spark go out here top.
In the discharge,
Yeah.
E functions would see some ripple if there would be.
Yeah,
quantum
would do
problems.
something funny, right?
It
Yeah.
seems to be sufficient.
Okay, so then we'll go back.
Yeah.
Carefully. You want to go back to the cat, right? Okay. So there you go, it reverses.
This is your
That's
your
normal.
charge.
Right, that's your charge.
Yes. That's your charge E function. And then short discharge.
Well, that's the charge you have to deliver.
Yeah, you have to
The
deliver
charge in
that.
there on the actual ions because of the hysteresis laws and full potentialization is actually greater energy on the ions than what we have to deliver. We only have to deliver electrons enough to make that high potential, and that's very quick, very small amount because there's not much mass we're moving. But the ions, the whole trick is for the ions not to be moving yet, to acquire the potential.
Guys, go
And
grab
then we
something.
quit paying for it.
Okay.
Believe me, that's a lot.
Fine. So how far are we into the?
Let's stop. I have almost 2 hours.
2 hours. And
Hour
Well,
50, we got a
51.
stop there, he's got it on his stopwatch.
yeah, I only show, I don't show the hours.
He does, okay.
Yeah.
Yeah.
So I have the
Today.
fine stuff.
Okay, we're rolling. Has anything changed, Frank?
Nope.
Okay,
All the
thank you.
same.
We have a real problem. Everybody does. Real. If you look at the curve, I look at what the Bush administration was doing. If all you have is a conventional scientific minds, basically classical. That's all you have available to you. So you're gonna go into the other stuff. They're doing the best they can. But it turned out to be real simple. We didn't have enough oil, we got rid of oil. We don't have enough oil pipeline, we got rid of it. We don't have enough gas, we got rid of it. We got rid of it. We don't have enough electric vehicles, we don't have enough time, we don't have enough power plants. But the bottom line is impossible. They have to build 90 power plants per year. No country will ever do it. If we started right now with a maximum national effort, 5 years from now, we will what's 24 hours a day, we could possibly have a power line. We'll be all over, sort of there. You can't bring them line fast enough. We can't build a gas line fast enough. We can't build pipelines fast enough. We can't build wells fast enough. We can get by and run all this and all that. The second cannot be done fast. So transportation. Well, the problem we're looking at is breaking the economy because everything we have in America is shipped on trucks. You know, we use stuff that came from somewhere else on the truck. And if you start, exact truck costs goes up. Look at your trains sometimes. Pack your train with truck trailers. So, everything's containerized and all that stuff. If you start driving those fuel costs, blah, blah, blah. Yeah, all of this stuff. All of it. So, curves show it's a great economy out in 2008. And that's the world. It's not just the U.S. It's all of it. I wish I could say that our scientific community is reacting to it. They're not. They're doing business as usual. We have various places where we have things approved. And not even looking at it, they just want to do exactly more of the same. But I'm really worried about it because you start breaking the whole economy. You got a real problem. People, economy start saving, the nation's crashing, Congress, they may not be. The next thing we want to do is like buy more stuff.
That's pretty good. So what's your weather been like down there, San Diego?
That should drop dead.
Lately, yes. Otherwise, the last 2 months, cold out.
It's pretty warm down there. Something's wrong.
Anything below 70s.
You know, I heard you've had a lot of rain too. Over. Yeah.
It's all heavy rainfall.
So it is. I think they're a little short, so they were screaming up here and water in there, and I drove it. What about the snow pack? Of course, without that, they can't get that bill.
Frank was telling me last night that they have, did you say double or almost triple your gas bill? Natural gas.
Four times.
What kind? No,
So my bill, gas, electric combined, January 2001 was 4 times higher.
I know, the natural gas went up.
no, but for business or for your house?
That's a house. Well, San Diego though, is not part of that. They buy their own office, the market. Right? You buy your own. I guess the county or the whatever, down to San Diego is not part of that. Further up California, they are on a system where they're buying it on the open market, so therefore they're paying fluctuation.
No, I'm saying,
That's right, they have a half of it. Oh, really?
and that's not the end of it. That's the reason I'm saying, that's the reason I'm saying, you're looking at the budget, the average citizen, what you're looking at is the flat of the real economy. They're going to match it down wherever they're trying. And I think it's trying to get the community to do this.
Some business just had to go.
Are they a mid-sized business or a bigger business? Well, I would not. Man, they have a lot of those, I mean, California's full of that. That's what John says he misses the most up here, being able to just go and get what you want. So,
This summer, and this winter, California last year was way better. This summer and this winter, well, really, after this winter, I think it's going to have enough pressure on the politicians to make them go over and check the scientific community, which is going to wake up and say, you mean we got a problem? But unless we do, unless we get those guys moving, we do it already. The drop dead date, I actually have system. If you know, the world economic collapse, the first quarter of 2004. You don't make that deadline, I was on the board, my family, the global heaven, about 2007. Just put it down. I got a paper in the Department of Energy website, please. Nobody reacted to it, so I didn't. So far, on scientific, we say that was the fuel cell. And then look at their lead time, before their fuel cell could be moving very much. The Bush administration has said, well, we didn't build properly, we didn't build it right, we didn't really get building. But that's the only solution you have available to you, that's true. That's absolutely true. They're doing the best they can find. That's what they do. Response time, too long. We don't have, the curve on the road economy is going like this. Now, response time doesn't start here, so that's the problem. The delay before we can actually do this.
I just know the last administration just didn't handle things properly. Very,
One of the last nuclear power plant that we like, the license for,
my understanding was it takes so long to actually get those online.
It does.
Just like you were telling me, like the generators, well, the build
That quarter is 3 years.
for hydro and for any type of generator. Yeah. Only one company?
Yeah, when you put your order in, and you'll get delivery in 3 years.
I mean, they are enormous, you understand, they are enormous.
No, they're not.
Well, we really have an enormous problem. It's not just the U.S. This is worldwide. Everybody has the same problem. We really do. I personally would like to see the Manhattan Project. I'd like to see, say, look, because of the scientific community, this is not business as usual. Let's look at everything. Let's look at everything that could even possibly be done. And then they find something that can be maybe work and develop it now. Let's go like this way. But they're not doing it. It's a matter of fact, I went and looked at the National Science Foundation's website, National Academy of Sciences website. I'm really unimpressed. I don't think those folks have no idea of the last 10, 15 years. Well, misunderstanding what they do well, but they haven't expanded anything. So I'm not really impressed with what they're doing. They're supposed to be our leaders sometimes. They're not.
I would agree with that. But I believe people are all caught up in what they do. They're looking away. They're tired when they get home there. You know what I'm saying, Tom? You got kids, I mean, you gotta deal with the kids. You gotta go home with my wife, my daughter, they gotta fight, I gotta get involved in the fight.
We've got sanctions.
You get tired.
We have sanctions against Iraq. And we're having to use Iraqi oil. So,
Well,
here on the one hand, we're saying
are
we're
we
going to
just
punish
buying-
you, and the other hand, we're
Yeah,
saying
are
we're going to
they
buy your oil.
supposedly buying that, Tom, and they're only supposed to buy medicine and whatever.
That is the dog, that, strong attempt they have to go through, but no, we're buying oil, we need the oil, bad. When the president, the former president, not president now, Clinton, made that grandiose gesture, oh, I'm going to release some oil out of the National Reserve. Do you know what happened to that oil? We didn't have any refineries to refine it.
They were at capacity.
They had to put the oil in ships, transport it overseas to where some people had refineries, refine it overseas, and put that back into other ships and bring it back. So who's kidding who,
Well, I heard we were at such capacity anyway, because we didn't have that many.
We've been closing down refineries steadily.
Yeah.
We haven't been building pipelines. We haven't been drilling gas wells. We haven't been drilling oil wells. Steadily, what the U.S. supplies, its own oil supply has been declining as our needs rise. We haven't been bringing anything online that's supposed to happen.
My understanding, though, everything that comes out of Alaska goes to Japan. That's what I heard.
If you can't deliver, if you don't have a pipeline or you don't have a mechanism to deliver,
Yeah.
that's basically true.
Yeah, I heard everything basically that was coming out of Alaska was being shipped to Japan. So, I don't know if that's, happens. You read a lot of it, and you just, take it for what it is.
Then we have the activist community, like medicine. That's a big bell-shaped curve. Some of them are nice folks. But the one, the extreme limit, the hard line, you really want to run the people out of the area and put the animals back. They want you to have a kerosene lamp for lighting. You don't want you to burn anything in apartments, you want you to put them close. And they really think they ought to get rid of the people or else, get the people where they're not allowed that portion of it, not all of it, but that portion. Sierra Club, guys that own the Sierra Club, they're absolutely adamant about it. They think they'll run the people out of there, make a pristine wilderness, bears and wolves.
Stuff in Rainbow Six.
Yeah. So people are not gonna stand for that. You're gonna have to provide the power they need. If you don't, the full government comes at you. Not just here, but I mean everywhere else too. We're not the only ones. Same thing. Everybody's going to do the same thing.
Deal.
I saw some guys come down, they preach next week. And these were supposed to be technical. They're gonna come down, they're gonna tell us, evaluate the community. And before we got through those, I told the folks that brought them down, help, again, find one of those characters, you need to have the other guy. He's not welcome, he's not good out in there. They didn't know him. They didn't even know how to measure. These were supposed to be out there. Well, I thought to myself, well, you know, it's obvious that the old police national have about those. They don't even know there is one. Of course, they're big moves, you know, their basic approach is just all start going to we have a big problem. The world has a big problem. You can't take something that's that disruptive, powerful, every nation, and then expect it, you know, everything's going to go on smooth, we have nice agreements, and we have a relatively stable situation, it's not going to stay with that. I don't like to see that.
People are looking for changes in the new millennium, so.
They're going to do something about the energy, they're going to get changed and curl their hair, I guarantee you, they haven't seen anything. And even in Huntsville, Alabama, they're sitting there with shade of GBA. And people using natural gas, which is always been cheap, they had the same experience we had, the natural gas, bang. Most of our citizens, you know, working black people,
Elderly.
they can't pay quadruple bill, things like that, to keep their house. Or the gas pump.
It's bad because you get the cost like that, you gotta pass them on to your customer, there's no way around it.
There's no way to go to.
My distributors say, hey, Gary, I can't afford another price increase. I had plexiglass go up on me. It went from, I was paying 54 cents to $4 for the same amount. That's too much. So I had to change it to a clear, because for some reason the smoke was just costing a lot more. Then, and most of my units were going over 50 feet. And I mean, their economy is just coming back a little bit. We lost our cans in Asia, and then Asia's crisis hit. The markets dried up. They all ran out of Hong Kong because of the China deal. And I mean, it hurt like hell. We need some of that back now. Yeah, I'm gonna go over that stuff with you on the amplifiers and the clarifiers and some of the other stuff that we have. Because it will open our markets, I believe, a little more. It's a matter of us being in a position to do this.
But we have to look at the cost benefit ratio.
That's right.
Such a big increase.
That's right. But, you know, I see the market coming back. So that's a very good sign, especially for someone, when we're at the top of this pyramid, in very esoteric high-end sales. The amplifiers, by the time they get to Europe, if I sell my amplifier for $6,000 a month, by the time they hit Germany, the distributor, the duties, the tariffs, everything else. That amplifier will sell for a little over, well, American money, maybe 13,000, 14,000. Okay? Well, I was working with my German distributor, who was supposed to take it and get it through, I don't know if he was using TUV, the regulatory, whatever was over there, which could have been TUV. The deal was, I supply the amplifier, he pays the cost, and we split the deal. I never heard back from him on that, but I think part of his market collapsed, which he was distributing from there throughout Spain, Italy, Germany, I mean, all of Germany, and then the surrounding areas. And he was doing fairly good. I mean, you know, not being there, it's hard to say what the market potential is. You know what I'm saying? So I have to really depend on those distributors. Tell me what they think the market potential is, what the saturation will be, what it's going to absorb, how much out of pocket it's going to be for the advertising, and everything else that it takes to do that. I mean, I just got from a man in Germany, like, I forget the name of that. And he was asking, geez, you know, I'd like to import this. There's a lot I
With all the crap on the top of
I
it.
mean, they're strict.
They're totally dead
They're
bad.
not properly, I
You
call
couldn't
them.
get 1 ounce of spark out of it.
Can I bring my
So,
battery
I'm telling these
that's
people,
from like Fiat?
I'm getting to this point right now.
It's a brand new battery I just bought last summer and it's dead already. From sitting for 3 weeks only. It shouldn't die every
12.67, that's over half. You got a long time to go, sorry boys.
It's been 2.5 hours since minus the time. Okay.
How many batteries did you get? Or how many series? You've been paying more attention to that.
That's one, Allen primary is charging 6. They predicted 4 hours. No,
But now, Frank, the CE marking is going to actually give you a better
I think
marking.
there's 6.
You don't think so?
It's the CE marking. It's not
4, no, it's 12, you're right.
At all?
12 volts, each one.
all equipment has.
Now, you know what the next part of the test is to see whether this is gonna hold it, so that's why they want to hold it 24 hours. Then you
What
know
if they get caught with
how
all
much
this?
they lost, and then dissipate them. And what they've discovered is
You
really
understand
remarkable.
penalties and
is
fines
that
and...
the batteries that are charged with a regular battery charge you buy in a store versus this method, this charge stays for at least 30% longer. You have 30%. In other words,
More
the
energy
light, you know,
potential.
when they dissipate it through plugging into it,
Mhm.
kind of watt bulb, one is going like this and the other one's kind of going out this. And when you end up, this one takes 30% more energy in it. Tom explains it through the electrons, but I don't understand. it.
Through the pulse charge technique that it does?
The pulse
or-
charge technique charges, it holds the charge longer, it activates electrons from there.
Right, yeah, rather than the trickle charge, which doesn't have as big
Yeah,
of
because
a effect.
well, you put it on a trickle charge overnight for 18 hours, and he flash charges the other batteries in 3 hours. And the flash charge batteries have 30% more energy.
Have longer life.
Longer
Right,
life.
yeah.
And then when they burned it out, then they gave them 10 minutes to recover again. Because
Did it
everyone will
again.
recover.
Sure.
Then there was 40% more. It came down a lot quicker.
Uh-huh.
Like in, you know,
In minutes
less
or
than a
whatever.
minute. you
Yeah.
know. But the one John's, from his
That's the
machine,
only thing that worried
held
me.
it for 40% longer.
Then the one
Yeah,
eventually
so
trickle
if you go in and
charge.
have a cup of coffee, when your battery's dead, you know you come out 10 minutes later, you'll have a crank left. With John's, you have 3 or 4 cranks left. With the battery just having a static electricity,
Do they allow
backed
units
up.
to go
With a
in the
normal
country for
battery
gas?
that hasn't had this type of charge, you only get maybe 1 crank left.
Mhm.
You know what I'm talking about?
Yeah, I do, I've been in that situation where.
Who hasn't? Yeah. So,
Let's just sit here for a few minutes.
is this camera on?
It's rolling, yes.
Another.
For instance, if we did TUV test on the amplifier, from the one tester, we able to get certification for Europe, for Canada, for Asia, from the testing, or are they individual?
That's where the international system is still in viruses. The US has been sitting there for years and years, blocking any
Why?
They are saying we are the authority on safety here. Implementing as a US standard is law here in
How long is
the
it,
US.
John, that
They
big,
forgot.
6-inch diameter?
Canada, Canada has been much more growing. So they will adopt international standards now for UL in order to declare compliance for Canada. And they are
CSA.
no, there's UL Canada. There is the UL Canadian mark. And there is CSA. And CSA uses USA. So CSA, for instance, is a national recognized testament in the USA. UL is a national recognized testament in Canada. So each of them can. But in order to do so, you have to also know the standards. Canada has been much more faster.
Well,
I think the
my
individual
distributor in
standards-
Canada, who's out of Ontario, told me that when
Getting on this for just
you
a
had
time,
a
just checking in with you, then you know
UC
it's okay.
sticker and see a new sticker from Europe,
On these tests here.
Canada will accept that. Now, is there truth to that, or is? You know what I'm saying, Frank?
Yes. I'm doing okay. You are actually not audience, you know that? Yeah. So you take care. I'll see this.
Canada is kind of holding a little bit of weight on that. Europe always was saying any type of equipment is used by users who are not familiar with any hazards. So we are going to protect those users. We are also going to protect the next level, which is a service person. Because they are entitled to also get shot. And
Well,
they
my-
have to be protected against unexpected hazards. They are familiar with most of the hazards.
See,
They have to be obvious.
what I'm buying off the shelf already has a UL sticker here in the US.
For what? For the,
For whatever prop, could be a transformer, could be a, that is still not the same equivalent to be passed someplace else. Being that it passed UL here. Okay,
it's
so,
not sufficient. Because they have different simple things. The supply voltage in Europe is coupled with like that.
if a transformer manufacturer tells me I wind it 220, 240, at 50 cycles, that's what they mean. And it has approval for Europe. Does that, would it bear that number or that C, the CA on the product, even though it's manufactured here?
But normally components don't carry exceptions are computer parts.
Okay.
They carry the marking because it's not required for components. Only running keys. But
If Packard Bell wants to ship a computer into Europe, they're manufactured here. They have to bear that mark prior.
they have to test it. So there are certain levels of that. The minimum level in order to comply with these laws is a directive. The directive is Europe-wide. So they are saying for equipment which is operated in the range of 50 volts through 1000 volts AC, you have to comply with the low voltage directive. This low voltage directive is implemented in national law. It's all the same across the board. You have to comply with these national laws or the directive. In order to comply with that, if you declare compliance to the directive, you have to show that we use harmonized standards in order to test it, whether it's EMC testing, whether it's safety
And
testing.
when the testing is done, they burn the product up for you. In your testing lab, you burn the product up to see what happens, or
We are applying reasonable signal formation.
my problem was somebody had told me, well, yeah, but you go over to a testing lab and you have to transform them, they're gonna burn that up.
They run tests on this.
If it burns, then you have a problem.
Okay, all right,
Then you have a problem
Yeah,
because it's
the
not
manufacturer
properly-
isn't
it's
providing
properly
it.
protected.
Like, I had some CSA testing done on a circuit board that was used for American Standard work. That makes toilets and water closets and that. We designed that sensor on the urinal, when you stood in front of it and you walked away, it would flash. We designed that, we designed for American Standard also, the hydro massage like that. It was all touch switch with membrane over completely sealed. When Bob and I did all the design on it, when I sent that in, everything passed except for, they didn't, when they did a high pop test on it, there's a space between the AC line and the traces.
So you got about
I needed to go like
2.5 hours.
further.
I got plenty of tape.
Oh, there's our tape light. Perfect timing, gentlemen.
Starting to really push that battery upward now, Tom. That battery, just the way it sits right now, has more charge in it than when we took it out of the package, even though it reads low.
And you let him unpackage it.
Okay, I'm gonna change the
Oh,
tape,
yeah, I took
gentlemen.
them out of the package in front of the camera.
Yeah.
There are certain requirements.
Frank?
Circuit
Yes.
board.
Stopping tape.
You ready?
Rolling tape again. Has anything changed?
Nothing has changed.
Frank is
1136 volts.
Yeah, you got a while, Frank. You got a while.
Yes, we had
Come on.
8 point, what?
Did you want him in
8.5
here?
volts last time.
Are you rolling now?
I'm rolling now, just during the tape changes, because everything else is going to pretty much remain the same.
Yeah.
Sitting and watching batteries discharge is like watching the grass grow.
Oh. No, I got your briefcase. I'm gonna put it back.
Okay.
I think over here.
I'll come get it, Gary.
Yeah, it's right here.
he has the right idea. When I was really, when I only was in charge of one bad, which is when the reason I'm gonna do that. I was using credit. And not using credit for the other, so losing so much, so my credit come out, that's it. This is intense, it's okay. I believe we can lose some badly. The motion can put in the rest of the stuff in it. I mean, what's probably more than what we can give the rest. You don't have to find that. Last year, twice as much. Couldn't do it if you do it before. Just try much better. Generally, it's better than the car service. Never ever did it. That's the stupidest thing. Never did it. But you gotta go park the pitch, understand what power that comes up. All the day, it's involved in crash out. What takes a little bit of distance from sources, make the magnetic field. You have 100% efficient generator, don't lose anything, but you got the magnetic losses. You transform all that. Shout, horsepower, transform that into magnetic field. That's all you get when you crank the shaft, is one of these magnetic field. And then you just install it. So what's that? It does a very simple thing. Charges is in circles. Works on positive charges, works on this way, works on the negative, works on this way, separate from the nine. That's all. It's all that gas, all cold, wasn't cold, it's all it does make it out. If you want to destroy it, if you want to steal it, instead of using the same thing, you use the parts of it. Not over the last way. As long as it's attacked. We're going to part of the physics, we've known for almost 5 decades. But this dye, this heavy separation of the sun, goes into the outer black, transduces it into a form that's used for the energy, pours it out of those channels. As a matter of fact, it goes enormous energy. About 10 trillion times as much as they pour certain capsules. So help me God, it's in the original paper by every side. And the amount of energy that pours out of iron circuits is just mind-boggling. And only the little bit tiny bit that skins down the wire and strikes it with a surface charge, it's converted into the wire, copper, electrons, all that circuit is. All the rest of it is clear as the sunset. So, what happens then is, we don't catch it. Back in those days in the 1880s, Maxwell was already dead. The guy was a prestigious guy, and there was 2 people discovered what we call the energy field of space today. That's not what happens, but that's what we call it monsters. One was pointing professor, and one was on the inside. The inside was self-taught, leading guy. Everyone took a look. Later didn't want to talk. But this guy, his question, when we teach in school, it's like this place, they're not. I don't want to go ever hear anything like it. They are great truncations, but they make math simple. But at least here's how you have the little unity system in there. Pointing never considered anything in this external circuit except the energy that actually is called the circuit, the inertial circuit. So he considered it a little skinny combo. He never even knew about the other, considered it. Any side of the here. He worked out both. So it's so, yeah, but the amount of energy pouring out of the tunnel is so great compared to what you're putting in the engine. In the 1880s, there wasn't no such thing as an active battery part of physics wasn't born, young other people wasn't born, can't hadn't discovered the electron, hadn't discovered the atom, nothing. Electricity was being proven. Flowing through the wires.
I can prove that it works. Here it is.
Yeah, so what they had is, it wasn't about a little less than 3 dozen electrical analysis. Well, that's it. Okay. The greatest scientist was Lorentz. Pointing never considered the other component at all. He decided to do it, but he didn't care. He was going out and say it from somewhere. He always said, no, sir, he put out those great out there. He didn't make it about it. Oh, how's it going? Good to see you. Yeah, nice to see you again.
Yeah, for today. I'm anticipating tomorrow being like very down.
They're around here somewhere working. I don't know.
We didn't go to lunch.
We eat much.
Went to their lunch place, they weren't there, so I figured.
No, we have to eat in today.
Oh, they go back room, back
No,
room.
they're not back there. That's a test thing going on. I don't think they are. Gary?
Gary's back, yes.
Anyway, ever said, didn't dare say anything about how great of a magnitude it had. So we talked about the angles. He said that the angle of flow was doing parallel to the current. And the amount that it was a circuit that didn't deviate. In other words, it's an energy. That's what I'm saying. He didn't dare say it in the magnitude of it. It was falling on a special motion. Nobody was waiting where the hell all this was going. Well, the greatest scientist in the world, that's the scientist who was Lorentz. Lorentz looked at it. He understood perfectly what the excited about. He understood pointing that he considered. But he was startled. How did he put his brain 10 trillion times, let's say, for a circuit out of that? As much energy pouring out of the terminal as anybody's putting in the terminal. Where is it coming from? So, he knew one thing, even the reference couldn't say that, or they would destroy him. So he said a crazy thing. He said, well, it doesn't get anything, it doesn't power anything, so it has no physical significance. So he originated it with mathematical trick. The component's really there in nature. I mean, you don't look at it when you look at solar. And they count only that little pointing component enters a circuit. But when we measure a circuit, we measure dissipation from it. The energy has to enter first, so we will be measuring pointing component. And ignoring it up, and we still do it. That other energy around every field and particle interaction is what's generating extra gravity out there to pull the spiral arms of the spiral galaxies together. I got a paper out there saying nobody really can tell you that 10 years that together. It's just humongous energy that they move around every second. So Lorentz said that I got 2 slides. I got Lorentz in a sailboat out on the ocean, big wind in the ocean. And he's putting his pipe and he's saying, only the wind on my sails has any physical significance. Back to my sailboat. Over next to him on the next slide, and we're trying to look and we're whole fleet of other sailors, all saving in that physical insignificant winds. Because they're trying to catch us. We don't try to catch us. You go try to tell the electrical power industry that one generator, you catch them up the end, what's that, power going in space. They say, you know, we'll show this to you. You have a damn one of them going back to the original convention, Lorentz, inside, went back, checked. Now somebody wrote about it. Went back and saw what they did. They didn't do what they said they did. So we've got a scientific problem. Mindset. Boy, is it fierce. It's been locked in there for over 100 years. And yet we unlock it. See, now we
You know, these dark ages.
if we go to quantum physics now, all we have is broken symmetry that I hold proof. I don't need to prove it. It already proves it. It extracts energy, turns it into musical energy, pulls it out. But it isn't in that put in there or they put it in and say, we did that like that was this.
Yeah, I remember you were talking about last time. I don't know what's going on. Read this.
Be sure the experiment runs okay, nothing burns up.
So you've been in the gray room, Doc?
I'm sorry?
Yes.
Michael's on the phone for you.
Oh, no kidding.
Go right here, push the button down. Thank you. Come on. Yeah, Frank's looking at some other stuff right now.
All right.
Which is good.
Well, I'll stay away. I don't want to over indoctrinate. We got what we needed across us. We did that. Besides, if he's got a question, he'll ask. No problem.
Yeah,
That's
I
no
hope so. Hey, let's let it do its thing. That's
Yeah,
all.
I just let it do its thing.
That's all that matters. That you say.
Well, we got the 3 batteries. That's the main. So accumulate some energy. We don't really have to run that other battery all the way down to do that. But it's much easier to test it, how much we expanded if we runs it all the way down. I think we can afford it, okay?
Sure. Yeah, it's working. You can see it snapping.
Yeah. Fortunately, Frank's good enough. He understands that ion current moves at a quite different pace from electron current. You don't have to, all you gotta do is just
Feeling the
mention it.
batteries out there.
Yeah.
That they're cold or not.
We don't charge that battery. John is not charging that battery in the normal charging battery. It's what I have drawn on that other diagram that we talked about last night.
Yep. And you can see that little snap, it's going. You just gotta let them charge.
I wish, if we really had our druthers, we'd have one of those little dynamometers that she was.
I know, but shit.
But I don't think you get them anywhere but Germany. That's the only thing I found on the net mentioned that they had one, but I don't know where they bought it. It didn't mention where they got it. It just said they had one. Some dynamometer shop that specializes in it somewhere.
They just don't make them that small. I imagine a huge lab that does maybe precision type stuff might have one, but it would be all computerized, Tom.
What they've apparently started building the little ones for is, that they may be building them now somewhere. They have a lot of work that's started up in robotics, for little bitty motors for robots.
Yeah, I would think you would use them there.
And they do use them there. That's the only place I know where to use them.
I gotta go hit UPS.
to say, I was keeping my eyes fiercely peeled. You see? It's straightforward, first thing you understand.
Okay. We're gonna go into a tape change. And rolling again.
we're going back to the one material. So there's very peculiar things happening when you start it. Comes back to who the adjunct. The adjunct is there to change that music. This thing, they're like that. That's not a technology that evolved. You transform that into normal power, put it back in input. You catch it, how people are receiving it, and you transform it into a lot. You make that surface power. And also, trigger the further, not only the power itself, not only the generator, power of the mind, but you the extra power. That is what you can have a crash program last 3 years. So we gotta go into all this stuff. It's not time to do that. But it's coming on and keeping up with the curve. All I do right now is you can't talk to national labs. People can't do it. Take the election. Everything out there, try to steal stuff. So this is not one. Yeah. I don't know how it works, scientific. I mean, they've been sitting ignoring. I mean, they had Nobel Prize when they tell them, well, that's what I meant, you know, 5,137. Correct. Move on. Things we learned since then. And parts of the know should correct. Because everybody's expert in what they're teaching you, so we better change that for them. Not expert. We have to admit them to be marble barrels. We have to tell everybody how great we are. That's all we know.
Yes.
Mark my words, if we don't stop the problems, there's no choices.
It's what you said, Frank, it keeps rotating.
Yes, that has the
You know what this thing is doing?
kinetic energy.
Hey, we're almost dead. But I'll bet you got one hell of a mass charge in these batteries.
So what is the voltage saying?
And what did you take them to?
9.5 volts. Okay, they recover, but the voltage itself is,
Well, it's current after that, Frank.
yes, we need to determine the current.
Yeah,
That's what we are after.
yes,
The charge, nothing else.
yeah. We need to determine the mass charge.
Yes.
You don't care what the voltage is, what's the mass charge?
So how would we most efficiently determine the charge? We could
Well, maybe that's a good question for,
discharge it into this guy.
your analyzer, yeah. Can you do that with it?
We have to have, so it goes down to 80 milliamps.
80?
Yeah.
8.
Yeah, 80,
Oh, yeah, 80.
80 milliamps. So,
Not ready to die, Frank. See, we don't know what charge was in this battery,
no,
but we will know tomorrow. You know why? Because this will be full again,
yes.
right?
We're going to charge it full?
Yeah, for 18 hours. Like it said, recommended. We just took them out of the packages.
Okay.
You're gonna lock these up.
Yeah, or we are going to determine their charge. So, what is the best way of
Well, you know what the battery is normally, where it sits normally. Right, any one of these batteries out here that's been, you don't have a meter, do you? We got one out here, Franklin. Okay, come on.
I have one charge of 32 major barrels. That's small. They sit in fine positions. Juniors pull that piece of shit together. 1865, for Christ's sake, in American Civil War. Something on the side. So, they're not supposed to be teaching them. That's what we're doing right now. Yeah, what's the price, bro? The motor's holding up real good. It's running right good here. It's been running a while too, so it might go a little while longer than what we think about. Because they turned the sign to me, it's not straightforward, it's not possible. That's what's really across the line, you like know what miles are circuit. You know, it's in the textbook, you know how to figure it out. It's certainly important to figure. All the decisions all I can do is keep getting behind that. About that time, you know, second you got sales. Hey, you know, possibly we will run for another time. This time, we got
Is the stitching holding up?
2 years.
Good to see you again, Allison.
Still there for the dollars. Next 2 years. That's why I work 19 days. Well, you've been good. We sure tell it now. Notice I don't stand too long. Going back and just going, semi-parallel, right, respectful. Ever since balance. It's just like walking on a stone, so to speak. I don't have any no response. So I don't have much balance on that side. And I haven't really watched that. It's so real easy. You have balance. You gotta have that feedback coming back. Do whatever works.
That's just a soundboard thing, or?
It's that missing disc part. Left right shoulder sitting on the curve.
almost done. We let it stop. We'll let it die. So there is an advantage to that, huh, Frank?
Yes. In accordance to battery manufacturers, they are saying that this pulse charging is more efficient, no question. And what I suspected previously that it's harder on the batteries is not the case.
No.
With lead acid batteries. So they are even saying it increases the lifetime of the batteries.
Well, yeah, it breaks the sulfation loose.
Yeah.
But in a gel cell, Frank, there's nowhere for the sulfation to go. It's a paste.
Yes.
So let it die.
We are down to
Yeah.
50,
Okay, that's fine, let it go.
50 milliamps.
How are we on the batteries charging?
We're up there where that one is static out there.
Or we could probably charge 3 more if we had them.
Well, if we had them all parallel. But see, Frank's trying to quantify now,
Oh, that's fine.
how do we determine, Tom, what's in those batteries?
You have to do it, and Frank, knows he would have to do that. You have to discharge those in a load and measure what you took out of them as work.
Yes.
That's the rigorous way to do it.
Right. But the only way we are able to get close to ideal is if we discharge them slowly. A lead acid battery discharged quickly can hold, still has up to 60% of its original charge, even after the discharge.
Well, we just have to see how we come out.
Okay, I've got 316 minus the 2 stops.
It's stuck.
Okay? 3 hours 16.
Minus the 2 stops,
Minus the-
which is about 10 minutes, Tom
Yeah.
said.
I have 3 hours 13
313?
minutes
Okay, very good.
and 29 seconds. And 71 hundredths.
Okay, good.
That's good.
So we have 3 hours, 13 minutes.
Disconnect our other batteries with it,
Yep. Well, I want Frank to see I'm doing
Yeah.
it. Frank, I'm gonna disconnect these,
Please.
right?
Yes.
Battery one.
Yes. Disconnect so that we don't change anything.
Battery two.
Okay. No.
Battery three.
What is roughly the temperature in here?
There's a thermometer right over there underneath the scope.
Yeah, it's sitting right here. It's about 70 degrees.
70 degrees, which is 21, yeah?
Yeah.
21 C.
Yeah.
Is there any chance to get the spec sheets for those batteries?
Well,
Like, what I'm looking for is the one, something from our Sonic here, which tells me exactly the discharge curves, discharge currents. So the capacity of the lead acid battery is actually quantified, and it tells you exactly if you are discharging at what rate, how many amp hours capacity you have.
500 milliamps.
So let's see if that's
500 milliamps. You could have 5, supposedly.
So are these the Powersonic batteries?
Yeah, I'm gonna go look.
So let me do in the meantime a quick to see where each of the batteries is sitting at. After 5 minutes after disconnection.
The Dow went up 400 points today, and Nasdaq went up 100. That's unusual. It hasn't happened for a long time.
Oh, 65.
Now they're sitting on voltage, right?
Hmm?
How are they sitting on voltage?
1260, 68, number 3 as well. So 1265 number 1 and 2 times 1268 volts. And this is 5 minutes after disconnection. So let's do some curves here. Let's see. It's probably pure gas. Don't want to do that. We probably didn't have the readings of this one. No? We can't see that.
I mean, it's very, very hard.
So, assuming that the batteries would be similar to those here, and they have a 0.5 amp hour battery here, at 10% discharge or 50 milliamps, we need to discharge it for 9 hours. And then three times the rate, we can discharge it in 18 minutes.
We got a 4-volt battery, right?
Yes.
Is it an STD 450? It's a 500.
It's not saying it. Made in Taiwan, and it's Radio Shack.
The boxes are in your,
Yeah, I got it here.
okay.
4 volts, 500 milliamp hours. Custom manufacture. No, they don't tell us the battery manufacturer. They are just saying OEM manufacturer in Taiwan for whatever, Tandy Corporation. So in order to determine the full charge of those batteries, we would need to discharge them for 20 hours at 25 milliamps. Then we would have the full
Maybe they
The
have
full
some other
discharge.
discharge curves on it.
Yes, they do, but then the capacitance is according to this chart less here.
Oh, okay.
So if you for instance discharge this 10% of the capacitance or of the current, then you only are discharging 10% less, so 0.45 amp hours. If you are discharging it in 77 minutes, you are only discharging 0.18 amp
Well,
hours.
that's quite a penalty then, right?
Yes.
Gentlemen, I'm going to change tapes.
Okay.
Cutting. Rolling again. Nothing's changed, correct?
Would the instrument measure that long, keep recording everything that long so that we're sure you got the measurements?
Yes. The only shortcoming we are having is that we don't know exactly how much capacity was left in the batteries. So we cannot really say it was zero. We can estimate maybe that there was 20% left also, but really it doesn't matter. It should be sufficient to determine whether it's more than one third of the fully charged battery. That's what we are after.
Well, we can see actually our efficiency will always be less than 100% because if we account for the other input of energy
Yes,
and all the losses and everything, it's never 100%.
sure. But if
But
we are,
COP is all we're looking for, we're only what we put in
yes,
is counted. So maybe we have enough to, if we got enough out, we have enough even giving up the other
yeah.
to do that. All we can do, I guess, is try and see. If it gets too close, we'll have to try to estimate what the devil that fan and motor was doing, but you have a better appreciation of that than I do.
Yes.
We don't have the dynamometer, so.
What we can do as a control measure then is use one of the fully discharged batteries and charge it again.
Yes,
we
that's
need,
right, we can do that.
but then we need again the time to discharge it in order to determine its charge. But what we could do then is charge one battery and then use this as a primary battery. Then we can
Yeah.
see.
He knows more about the responses to the recharging and all than I do. John, you need to talk to.
I was looking for the damn battery on there, but they don't show the curve.
Yeah.
They are probably quite similar to those here.
Yeah.
So, 500 milliamp hour battery would be fully discharged or the full capacitance after 20 hours. If you discharge it at a rate of 3 times the capacitance, then it's only discharged to 18%. Oh no, not 18%, but
3 times 18 minutes, you said?
no, 7.2 minutes. So
Right.
18.18 amp hours.
Right.
In other words,
You only
you
discharge.
penalize yourself for fast discharging, John.
Yes.
That's what he's saying. If one hold up for fast discharging really what the battery will do with what's in it.
Right. Right.
So he's trying to give you credit for what's actually in the battery.
So if we discharge it rapidly, we only catch whatever 20.
Oh, so you mean like we did in the beginning?
We only catch 35%.
Oh, I see. So
We
if you
need to
go
discharge
slow.
it slow.
We have to do it
Okay,
over
so
20.
do you want to do it over 20 hours, or do
Yes.
you want to
Yeah.
do it over?
Yeah, let's use one of the batteries. We have 3 available, and in accordance to the measurements
So
here.
you want 0.025 amps?
Yes, 25 milliamps.
Okay,
Exactly.
go to it.
You need to put a load on it, put that against a resistor or something.
Right.
That much of
Because
it.
this won't do it?
No, I cannot program it. You know, I would have had an electronic load,
Okay,
which draws a constant
25
current.
milliamps. Okay,
But they were bulky and heavy, so
so you
I
want to draw
didn't want-
25 milliamps.
Yeah, but see, as the voltage goes down on the battery,
the
The
on a
current.
given fixed resistor, you'll draw less current. The
Exactly,
current will
that's
also-
why it would be nice to have an electronic
Variable
load
load.
where you set a fixed current,
Fixed current draw,
Yes.
yeah.
independent from the voltage.
We don't have anything like that.
Well, you know what you can do? Put all 3 of them together.
No, he needs to save one of the other batteries to
Okay,
do a test on
okay, put
Power
2 of them
load.
together, Frank. That's 1,000.
So what would we,
John, how long
What would we gain?
would your scope read current if it's,
Long time.
huh?
It'll read that forever.
What I mean is, will the scope continue to do the?
Yeah, it'll
20
continue.
hours and record it?
Yeah, it'll keep going.
this guy does it as well.
Yeah.
So we could program it to
If we can't get the
Record.
constant draw, at least we can get the accurate measurement over time that we do draw.
yeah.
And draw a little more on the front end, and then we should cross the ideal point somewhere in the middle and then a little less on the other end.
Right, and we can integrate here
How do we do that,
over
Frank?
time.
That's about all we can do with what we have, since we don't have a program.
We can program.
So we penalize ourselves by drawing max?
Yes, if
Yes.
you quit
We
discharge,
only,
it's a
we
severe
only
penalty.
are going to see 35% roughly
Yeah,
of
it's
the,
a,
of
it's a
the
bad
charge.
penalty if you do that.
And
You
then,
throw away one battery.
and also, we need to watch for the lowest voltage in all cases.
Okay.
So if we slowly discharge the
Well, the scope will watch. I mean, it'll run continuous.
You record also, right?
Well, yeah, it'll record, but only record if you tell it to record
Yeah, we need to record the readings, so.
for 20 hours.
Yes,
yes.
that's what I'm saying. You
Can't
won't
do it.
Can't do it. How long can it record it?
Just as, it'll record in real time. It'll just keep running in real time.
No, I know it'll keep reading, but I meant the storage. Can you ever so often have it read and store, and later read and store, and later read?
I think you can.
If you could do that,
Yeah, let's go.
Frank would have a series of even
Yeah, right,
spaced
okay, all right, I
readings.
get it.
Yeah.
We're gonna- we're gonna put it in.
That seems to be
So, let's-
reasonable.
Okay, so
How
let's
much
see
time
here.
is left today?
Let's see. Meter,
If
we
we
want the
would,
meter. We want DC voltage, right?
so if we,
Save, recall.
what we could also do is discharge it at this rate where we have 20% less and account for the 20%.
See, that's what I'm saying.
That's okay. If it's-
Yeah, as long as we.
That
got
way,
time
it's,
for it.
we're at least trying to, correct for the,
Exactly.
penalties.
So
So,
4 hours
So at 10,
at 100 milliamps.
100 milliamps.
Yes.
It should go 4 hours.
it should go 4 hours, and then we know that we only catch 80% of the charge.
I see why he wants to go 25.
Okay.
He wants to catch all the charge.
Yes, if you wanted to do all of it, you'd have to discharge slowly, but then
Yes.
also, you know, we got to kind of jury rig around the.
But are you gonna do this, Frank, in parallel like you charged him?
We could do that as well.
Because,
Yes.
because you did charge them all
Well,
together.
he was going to use one representative battery. They're all just about the same, they're very
Yes.
close.
Yeah.
So,
And
one-third.
he was going to use one battery for.
Or they calculate the rest.
Yeah, and then he
Right.
was going to use one battery for sort of a makeup test if we don't have a dynamometer on that motor. And that's probably a pretty important test for him to do.
Okay.
Yes.
Well, do whatever way you wanna do it.
Yeah, he's got a good approach there.
Okay, so then let's use, do you have another new battery?
No, we
No, we have
we have
exhausted
these
that.
4 batteries.
Okay,
We could take this off and charge this.
okay, good, that's a good idea.
We could quick charge this.
Yeah.
We are going to use number whatever, let's
This
use
will take the
numbers.
primary charge.
No, not charge it, we are going to charge it here with the motor. We are going now to use one of the batteries
Okay.
and charge this one, primary. So we are trying to recycle.
Okay, so which battery are you going to use now as the primary? Number 3?
Number 3.
Number 3 now becomes a primary battery. The old
Okay.
primary is now going to
Plus
be
is yellow.
a charging battery.
We put it all away
Do this.
so that we have something running here.
Okay, so,
Yes,
These are the-
this is your voltage. So this is in parallel to the battery. And just measure the voltage. 60 something,
okay,
65.
so then this would go, no, it's already hooked up, isn't it?
Yeah. So
It's
we
not.
have the meter in here.
Yeah.
So we need to go from the minus.
Food dogs
No, we don't use coffee.
Right.
Didn't use it. So we're going from the minus of this battery to the plus. Yeah.
Plus of this battery? Go ahead.
Right, but we need to hook up the other one,
Okay.
and let's this time integrate here. Let's try to integrate. It's all voltage. Yes. And then,
Oh, I see, that way you can tell exactly what you got out of that battery.
exactly. Right, so this is plus side here.
Yeah. I get it, right? I got it now.
Okay.
I see, that's clever.
We have to find really
What's there?
all cross checking on how to quantify it.
Okay,
And that's
and those you're saving.
right. And the savings, I will use one of them to discharge it.
Okay,
So we're going to use this one. This is plus side. So this comes from here and this goes to here.
right.
So now I'm going to put that on integrating, and we are going to have amp hours. So menu, select menu, okay. Modes. Okay, inrush current. Only thing I don't know is my integration time. If I'm entering something,
Yeah,
it shows up as another number here,
yeah,
as a tens, no, as a
Right.
10 digit and not as a 1 digit. So I don't know why. Oops, maybe here. 3 hours, I can do ballast mode. Oh, I have a ballast mode. I don't need it now. Ballast mode, I don't want that.
Mhm.
Integration done. Okay, good. Now I can read.
Mhm.
No, that's fine. Oops.
So that will time it, right? Right.
Let me switch. I got the wrong time again. Menu. 1, 2, 3. Rush current income. Integration time 0. Okay. So now I want the reading to be in.
Volts, amps, watts.
Yeah, but if I'm in this mode here, balance mode, I want that, harmonic mode, I want display. Display. So the display function do I have? Let's find that. No. Yeah, manual.
Board.
Rush current 3 hours.
It's interesting science.
Okay. And now let me just verify. Set the word. Integration displays integrated values.
You can do it,
These
so
are and hours, what hours?
Did Gary say you needed to come back
VA,
tomorrow?
VA hours or it's not.
In the morning.
I think we need to integrate in hours.
yeah, right.
How would I get that?
We'll read the amp hour.
Yes. Okay. Integrator is run.
What's done?
What did all these gather in
Not really
the
sure.
Do they all measure around the same?
Yes. Yes, roughly.
When I
Let's do it again.
made a selection, I got the troops with
Then you,
or I got what they want with the numbers. Can I give that to you?
it's quite an intricate machine, Tom. To get it into where you want it. I'll try to get that down.
Yeah.
Did you and Lee and everybody fight with it? It's like trying to program all this.
Yeah.
Yeah, I got it. All right. I got both. Yeah, I got it. No, I got it.
Yeah, you know how this being long, food change up and all the dynamics
Yeah.
going on, and I just figured I'd
I'm
get
gonna walk out
it
right now and get all that stuff so I don't forget it.
Okay.
Turn.
What I don't want.
You want to integrate, right?
It is integrating, but it's integrating now the current, and that's what I don't want. Okay.
Now I'll get this.
Well, let's see, Frank. That's how you do it, right? 0, 3.
Is that it? I don't know. Well, maybe if I need to replace it, well, I never even noticed that.
Maybe you just start and it'll start showing.
What I'm trying to do is have it read and out to integrate over and time.
That battery is locked solid, Tom, it won't move.
I'm sorry.
That battery is just locked solid, it won't move.
What do you mean it won't move?
It won't move, just stays right there.
Won't furnish any power?
No, it just stays at that voltage.
Oh, okay, you mean the voltage is holding up?
Yeah, it doesn't go down, it just stays there. It's like there's a lock on it.
Okay, I got it. To do what it's
You
supposed
got it?
So it's going to
How much power you
integrate
doing from it? How much amperage?
Huh?
How much current you doing from it?
We're gonna draw about
Yes.
what, Frank, about 120 to 30
Yes.
mils? You ready?
Yes.
Moved it. Thanks.
So it times.
We're not getting anything through here yet. Do we have this right?
I have the
Minus,
So plus, minus.
plus,
This gives us a battery voltage.
okay, we don't have this,
We
so we need this
Yes,
plus.
definitely.
Okay.
Nothing like connected.
Okay, so we have a nut, 110, 120
No,
mils, yes. And I have the timing on this one, yes.
yeah. So you gotta let it go, right?
Yes.
Find out what you got in there.
Right.
How'd you get it to the 20 mils? Exactly.
120 mil.
I mean, how'd you get it to that? That's just what it turned out to be?
No, the motor was designed for 12 volts.
John designed it.
Oh, that's the design.
Yeah.
Okay, gotcha.
One designed for 13 or 14 volts, it was designed for 12
I'm
volts.
getting at, we didn't put another resistor in there, no way.
No.
So it's a
Okay.
combination of the
Yeah.
Yeah.
coil itself,
Yeah, that's
the
good.
coil resistance, and
That's
the
good.
switching.
That's excellent.
Well, it's been moving though, huh? I don't see it moving.
Well, it take a while.
Yeah. Yes, I don't know why we don't see anything.
Well, we have another.
Because we cannot see.
Well,
Really.
okay.
That's what we determined. We cannot see it, so it's useless
No,
with this guy.
not that useless.
Only will give us kind of RMS or an average.
And you're recording.
See, we're recording right now, Frank, come here.
Okay.
See, look,
Yes.
so I guess what we can do is take this and save this right here.
So this is the
Save,
battery voltage.
save, DMM data. Right, that's what we want, right? Data 1,
Yeah.
right? Save, okay. Supposedly we save that. Now if we go back over here, recall 1, right?
Yeah.
You know what, recall. Save current setup.
I gotta run an errand. I'll be back. Okay?
No, we are just measuring the voltage.
It's doing it.
People that mad at me.
Save. Save. Okay. Data one is saved.
That is that.
It says it saved it.
I'm sorry?
It says it's saved in here.
Yeah, I'm good.
Is that running faster, Tom? Frank, is that running faster? This seems like that's running faster.
I can't tell.
Hard to tell. We can time it on this one here. So if we
Yeah, let's do that.
put the
Put this scope
this
on.
scope across, then we can time how many milliseconds it takes. And if it's more, then
That seems like that's running faster to me.
this goes here. So we had almost exactly one second last
Right.
time.
Okay, Frank, go ahead. Remove. It's coming up like mad, huh?
What's going on?
That battery.
It will, from the other thing.
Something about the other battery.
That's one of those we charge that you're running.
Yeah,
Yeah, it's gonna have.
Seems like it's going faster.
It's gonna have a.
See, we pulled the hardest test of all. 3 at one time.
It's okay, it's good.
Yeah.
What we're really looking at is more ions to collect energy. So when during that momentary pause, the ions are not yet moving very fast at all. Not costing us much. We need that, a lot of potential on them right then.
Seems like there's a lot of potential in that battery.
Yeah. So the more.
What did you show that up?
Yeah,
So a little bit higher than previously. So we have
On a lower voltage.
1.1
See, John, from any.
second.
Any potential.
Wait a minute, there's something here that I gotta get
Yeah.
in my mind, Tom. How the hell can it go faster on a lower battery?
It goes slow,
Oh, a little slower.
a little slower, around about 10% slower, because the time here is 1.1 seconds.
Okay,
But it's working about right.
okay.
But it's still 12 volts.
Yeah,
So-
it's still sustaining.
See, the
See?
beauty of the 3 batteries, John, is from any potential. If you can keep the charger from moving, assume the perfect case, no
Right.
one to charge at all, you can collect as much energy as you wish from a potential without cost during that no movement time, depending only on the charge that you have available. It's simply joules per collecting kilo.
So actually what we just did here, Tom, is we took one of those batteries that we charged and we moved it to the motorcycle.
Well, what we're doing is we're proving that's real energy.
Yeah.
It's real working ordinary energy that run motors and turn fans and power lights. and all
Okay,
this thing.
I just want to know which
You know,
direction.
it's not
you
some
want.
kind of electrostatic phenomenon or
Yeah.
anything like that. It's really doing real work. See, in a COP measurement, we only get credit for what can be done as real work. And that's what Frank is doing. He's
Okay.
converting that into real work.
Nothing changed.
Okay, thank you.
At least giving us a proper time for this.
What I like about this one, we got exactly the same load, you know, that motor had exactly the same fan, exactly the same pulley, everything's exactly the same.
Yes.
There's a little bit of change in speed, but not much.
No, it's getting close to the 1 second. So it's maybe
Yeah.
a little 5% slower. So we have roughly 2400 RPM.
I believe we're also going to increase the voltage for a little while on the battery a little bit. There is another effect which is very difficult to explain. The process we use has an after effect that's beneficial, and so the voltage should actually climb a little bit. as we go.
On these batteries?
Just a tiny bit, not much. It won't be much of a thing, but it will move a bit. It'll jump around a bit.
Because of the
No. It's an effect inside the battery we create. I'm looking at it on the meter here, and it's doing about what it should be doing right now. Well, that's a good test. That's a load test. That's exactly what's needed.
so it's 12.6 now. It used to be 12.65. So it's going down a little bit.
Yeah, a little tiny bit.
Do you want to lock one of those away in the security box right now?
No. No, I want to use one of them and try to discharge it. So I need 24.
I give up one battery. I've calculated this in my head, Tom. $120.
I'm gonna wait and see the numbers, because there's quite a few things that's got to be added, and so Frank's got all that prepared, so, you know, it'll come out, what, you know, what he is doing is a good procedure.
Find resistors, right? There's drawers full. There's more back there. Get the big ones. The big ones, the wire well ones here. These are what, power ones? 120 ohm? Well, 120. Let me think here. We need a 330. Divide by 3.
No, are these 5% or 10%?
They're 5%. 330 divided by 3. Johnny's good at that. $125 ohms.
Yes, 111.
Well,
Both are
the other way.
8.5.
Okay, so 330, let me have one 330 off there and use 147. Well,
Yeah.
let's go better than that.
Yeah, would be plus or minus 5%.
That's right.
You made a guess. It's always more.
Okay, I got it. $332.
Okay.
Shit, watch me be wrong here.
Getting better.
Getting better. 330, okay, let's, 330. 680,
110.
that would be 680.
Let's,
Two, that would be
let's use
4,
that in
right?
series.
Wait.
330.
No, I gotta do something different here.
What will you get to?
I think we need 2 more. 680.
680 divided by 4. Yeah.
Yeah, you need
2 more.
2 more. But these are 1%. Now you've got a 5-watt resistor. $113.
Okay, 113. And
Yeah.
one is
8.
8. 13, 120, 20 something. We'll do it. Almost.
Well, wait a minute.
We can
Here, right?
calculate
Got
the
it.
difference.
I got it. Here. You need 120, right?
Yes.
Take this wire wound pot and bring it to 120.
Good. How many watts?
What we read. Mm, 120.
Would you like some tape on that? So it doesn't spin?
It won't go once you get that. 119.8. Is that close?
That's close enough. The only thing I don't like is, yeah, that moves for any reason. Then I have unpredictable circumstances. I rather be close and know
Use the other
exactly
one.
the value.
Don't worry, I'll find you something.
because under
I'll find you something. Watch this.
temperature is my
Second here.
I rather go with something that I know that I can
And then calculate.
calculate it.
Yeah, that's good.
So it is
140, 50.
it will anyhow change this temperature. So
Yeah, well, see, once you heat the pot, it's gonna go back on you.
let's use the one that here. That's fine.
Okay,
That's good
okay.
enough because it's going to change its
Right.
resistance once it's
That's the 680s, right?
Yes. Let's use that. So then we would battery number one.
You have that at this.
Somewhere here. On the hallway. Again. Withdraw 100 milliamps.
Oh, I see, you're gonna go,
We have 4 hours time.
I thought I had one of those great big spiders. With all that shoe stuff I got around here, it would be. Oh, well, can't have everything, that's all.
It's like a new timer.
the current and see how it changes.
120, where's Frank's little calculator?
It's in here. So let me see what it does. There it goes. 107.
Okey-doke.
106. 106. That's good enough. It's a little bit higher. And it's, what, 6% higher? Because of the higher
see it.
Can lead her up.
Just keep a little bit so I can see it.
Okay, sure.
Before I can read it now.
So 106. Discharging number one. Let's go number two. Number
105.8.
Can you shut it off this way?
No, it will go off. It's solar panel, solar powered. So we have
I'm glad that works out the way.
105. It will go down a little bit with the resistor heating up.
It will.
Yes. So we started at
2 minutes ago.
150 at
So it's put real power.
10 p.m.
Holding up pretty good too.
Computer says,
and the current
about 2
goes from
hours.
106
See what happens.
to
Yeah. Find porno, but I can't find anything else. That would be in my computer. Isn't there a calculator in this thing somewhere? No.
I don't know, John. Probably. Check under, where we got your, system tubes or system,
Oh, yeah.
see what you got in there.
So now we have 2 tests going on, the battery discharge and this one.
Yes.
Yes, he's,
Yes.
in the field for that battery, they're powering it, and he's also doing a test over there for,
discharging one of the 3 batteries.
Balance between this shot that I have between the battery and the readout and this that's going on here.
you
Yes.
can have a pretty good feel for it when he gets through pretty good set measurements. Over here, since we didn't have an anemometer, Frank is doing a measurement to arrive at a reasonable conclusion of what work is being done there. Weren't able to find a small, they were all big.
But we are keeping in mind that this is only 1/3 we are using now.
He's trying to calculate everything that, he can calculate, so,
Yeah.
which is good. That's exactly
Okay.
what.
Trying to approximate
That motor should run 99 minutes.
this way how much charge is in the battery.
So you can compare the two and see
Yes.
exactly how much. Good. I'm gonna count tapes, make sure I've got enough for these 2 more hours.
It's a 99 divided by 60.
Tapes.
Oh, there's a little bit like that. No, it'll be.
That motor,
Things will be.
okay, Tom, that motor should run 1.6 hours.
Okay.
This over here.
That would be times 3,
1.6 hours?
We'll see.
1.6.
We'll see.
So
1.6583333.
Frank has a time when we start.
Yes. So we had 3 hours and 13 minutes charge.
for the initial?
Yeah, so should run, yeah, somewhere
Okay, good.
an hour.
Okay.
An hour probably, hopefully an hour. This would at least say that we have 1/3.
So however to charge that.
Total 3 batteries should run
No, if this runs
4.97
for an
hours.
hour, we are fine.
What did the initial battery run?
Well, he's got another correction factor he's taken into account.
Okay, but what did the original battery run?
I didn't record it, he's got it recorded.
The original battery was running 3 hours and 13 minutes.
It's 120% efficiency.
So we are gaining 20%?
Yep. Calculate. Right to the... It's been 120 mils, right?
Yes, it's fluctuating between.
Okay.
I cannot measure more accurately,
Okay, no,
otherwise
that's fine.
the resistance would be.
And this
so
battery is at
high.
12,
It's a shunt.
so we are supplying a load at the, again, from the primary battery.
Yes.
So the balance remainder will be left in that battery.
No, actually, when we know that this battery runs for more than an hour, we know that we have. Unfortunately, we didn't know how much was left in those batteries. Yes, we discharged them, but how much capacity was left? Was it 20%? We can estimate.
Yeah,
Maybe
right.
it was 20% left.
Yeah, what's going to be, the balance is going to be left in this battery, because this was the primary.
Yeah. Yes.
Right?
Sure.
So,
we know.
however long that runs, if that runs 1 hour, then that's 3 hours total between these
Because this
batteries.
one will have the same balance.
Yeah, it will have the same balance left in it.
So it will have.
Theoretically.
Will have. We used it for 3 hours, so it will have roughly 10% left, in accordance to these numbers here.
It's 160%.
I'm thinking that when he accounts for the motor and all, he's got enough figures. that,
Yeah, well,
you know, he can get it accurate.
I forgot about the motor. I was doing that
Yeah,
calculation.
he'll show, he'll show. Frank's trying to determine that now. He'll have a good feel for it when he gets through.
To me, like, it seems like it's running.
Let's estimate how much mechanical energy.
That's why I wanted that inch-pound scale, Gary. I could have told you.
So it was a 15 CFM,
Yeah.
roughly.
Yeah, 15 CFM per minute. So that's, it ran 3 hours at 15 CFM per minute.
That's 180 times 15 in terms of cubic feet.
Yeah.
How you convert that to joules, I don't know.
Wait a minute.
Not easily. Flow rate. We have flow rate.
Yeah,
Cubic
flow rate.
feet per minute.
15 CFM
Yeah.
per minute times 60 minutes is 900 CFM per hour. Right?
Mhm. Yeah,
Times 3.
yeah.
Now 3.13, which is 13 over 60. Well, that's minutes,
Yeah.
3 hours and 13.
So it's 2,817 CFM in 3 hours.
But how do we convert CFM?
Yeah, well, I put the 13 there.
But how do we convert CFM? Want me in your book
He
here?
borrows on a new book, right?
There may be a conversion factor. I'm sure there probably is.
You know, I looked all over for these conversion tables and these factors, Tom. It's like disappeared.
No, it's out there, it's just,
Well,
It's out there, but
it's
it's a
obscure.
specialty type of
yeah,
thing, so. that
people
you
don't
can-
use that often.
Balancing will be left in this battery, which I suspect will be about 12.15. Should run an hour.
I'm watching your meter staying up at 12 now, more than staying in the.
Oh, yeah.
Hanging in there pretty good.
We are down to 104. Okay?
Yep, 104. More, Frank?
That's all? Should be.
Yeah, no bad, not bad at all. Those precision resistors stay almost damn on because the amplifiers don't do it.
What are they, 1%?
Yeah, they're 1% nailed. These suckers,
military
are
grade.
hot, they don't drift.
Yeah, that's good.
Military grade, that's good.
That's what we need.
You have another chair? So-
I will get you anything. you
Well,
want.
I'll get it for you, Frank.
Thank
I'll
you.
get
Can we find that on the internet somewhere, Tom?
Probably.
Probably, I don't know what to look on that.
CFA.
You can adjust it, there's a thing right on the handle on the side.
Thank you.
Yep, you can raise it, lower it, do what you want to do.
Ah, good.
Yeah, it's, no,
Cubic feet per minute should be a power type of progression. And then that times the time would give you the total energy. But it did that. So that'd be an estimate.
It's a mechanical measurement.
Yeah, mechanical energy.
Well, we're gonna do so I'll let
Frank, you want any tea or anything?
Oh, not right now, thank you.
It's 160. We need to go to the mechanical engine. You're gonna have to go to search engine. Yeah, just go to favorites. Favorites and go to Google. We will figure it out.
So these are ball bearings, yeah? Do we know
Yes,
roughly
they're ball bearings, they're 1%.
1%?
Yeah, they're not very much drag at all. The only drag is the magnet,
Yeah.
okay? And it's about, these are pressure contacts. It's difficult to turn if you go out there, so, and it's a belt.
Yeah. So
So
we have,
it's running about, I would say, equivalent to half an inch, quarter of an inch, I think.
yeah.
Less than that, maybe.
So the
The drag is constant.
drag.
Yeah, it's constant because it's a pressure brush.
Yes. And this.
And the fan is constant here, see?
Mhm.
You know what it's come out of, don't you, Frank? And I bent the fin so the beaver fan more.
Yeah, yes.
It come out of a tape recorder,
For this
out of a Rotary tape recorder.
AC motor or?
Yeah, AC motor.
Ah, yes.
I was looking for a big one for that one out there.
Yeah, we have to make it so strong as well.
So you have to convert it mechanical.
Yeah,
Okay.
and if I had a scale, I would do it for you right now.